Hi, I'm Sergey Kuznetsov, and welcome to Chicago Crystal.
Welcome, Sergey, to Chicago Crystal. It is great to have you here. I've been seeing some of your contributions both on the forums and of the compiler, and I'm just super glad to have you here. How are you doing?
I'm doing quite well, and thank you for the invitation. I love to talk to the people and just share the information, so I hope it will be a great conversation.
Yeah. Just to kind of kick us off, I've seen some comments you've posted about when you started programming, but how did you get into programming, and what got you interested in it?
Oh, so that's quite interesting. So, like back in the Soviet Union, that was like when I was age 10. I just moved from Russia to Kazakhstan because like my mom like married to my stepfather, and so when I moved there, like at school library, it was not a huge library. I read all the books that they had, and the last book was like tutorial for the FORTRAN.
Really? So you started with FORTRAN?
Yes, and I learned it without any computer.
Man.
I learned it without any computer, but later on, like I enjoyed it actually because you see, like I always love puzzles, and I still do. And like any technical challenge for me is a puzzle, so that's why I really love technical challenges. So I read that book, like I understand the principles, and later on, while I was still like 10 years old, like I had the aunt, like from like the relative from like my stepfather, who was a computer engineer at Academy of Science in back in Almaty. That's where I used to live from age 10 until age 26 when I came here. And yeah, so she was computer engineer. And when she visited us one day, she said, like, do you want to see the computers? I said, sure, of course, I want to see the computers. It was back in '83, right? And
Yeah.
I just came, like I came to visit her to her lab, and she started to show the computers. Like, wow, that's cool. I know how to program it. This is, are you kidding me? Like 10 years old boy, and no, not many people, only few engineers, back in Kazakhstan who can tell that they know the programming, right? But I did the programming, and so like they asked, what can you do? I said, like, okay, I can do this example. So I built the example, there was few mistakes. They helped me to fix it. I'd run it, and it was working. So it's like, wow. And then like they said, okay, like you just probably learned somewhere, and that example. Can you do this one? Like they gave me some task, and they explained what needs to be done. I was able to write
Wow.
the Fortran code, and it was executed. They said, wow, you're like a computer mage. That's how I get my nickname. So like I'm the
No
computer
way,
mage.
really?
Yeah, like I'm computer mage for the last 37 years.
Wow. And this was like 83 that you got your nickname, right?
Yes, that was the 83.
Wow.
Yeah.
It's the old man. That's crazy. That's a really cool handle. I like it.
Yeah, it's good. Like sometimes sometimes I said I drop from computer and said just mage, and all my friends actually name me like mage, but in Russian like magich. Magich, it's some kind
Oh,
of modification, so it's kind of mage, but still some kind of magich, whatever it is. Magich means the same, just mage.
okay. So you're in the early 80s.
Mhm.
You are you're kind of impressing your Fortran skills and stuff like that. And then how did you kind of get from there to here? Like, what did you do next?
So I started to come to that lab to that lab quite often and help them. So they gave me the chance to play with the computers, with the big ones. So that was IBM 360, IBM 370 clones.
Oh, wow.
Also some PDP 11 and VAX AMS.
Okay.
Yeah. So then at the same time, around like 84, 85, we had some kind of kids club over there where they also taught the computer programming.
Wow.
And that was Yamaha MSX. I don't know if you heard about it. Yamaha
No.
MSX, it was like in the Japanese computers. It's like personal computers, mostly for the Russia bought them a lot. for the Soviet schools, and it had MSX DOS, which actually the MS DOS built for that Yamaha MSX, which was based on Xilinx Z80.
So did the MSX DOS come first, or did the MS DOS come first?
No, that was MSX OS, which is like just like copy of the MS DOS. It was exactly the same, but only for the Yamaha.
Okay,
Yeah,
interesting.
and, I know, and that was back in '84 or '85. And after some, like there I started to learn basic, like all that stuff. But because the FORTRAN, and so for me it was quite easy. So, like I was like for me it was a little bit lazy, I would say. Like I was quite lazy over there. So mostly like I was going there to play on the computers because I see it was like lots of the really good games. And then like back in the 1986, that lab where I was going to, they were able to get the first IBM, not PC but XT.
What's that? I'm. There's a lot of different IBMs here. So IBM.
No. Okay. Initially it was IBM PC, then it was IBM XT, which was like 8186, and then it was IBM 80, and then it's like all that stuff like 386, 486, and whatever.
Okay.
So before like 386, they named it as PC. It was 8086. Then it was XT, which was 8186. Then it was 80, which was 182, 86, and then this 386, 486. 586 became a Pentium, then Pentium 1, Pentium 2, Pentium 3, whatever. But yeah, back then, that was MS-DOS, and I started to learn assembly, C. Later on, it was like C++. Too many languages.
That's classic.
And by the 1993, so at the neighbors' labs, so the guys start to build their UCP host. They were just to send the mail, and like they installed first Linux over there.
Really? Wait, when was this?
That was in 1983. So 1993.
Really? I thought Linux didn't make it to like 95, 96. I didn't realize.
No, Linux.
When was Linux?
First version, the Linux first version of the Linux was introduced in late 1991.
Oh, really?
And so by the 1993, like mid 1993, it was version like 0.9.3, if I remember correctly, of the Linux, and it was the 0.9 Slackware distribution. That's what we've used.
Okay, interesting.
Yeah. But around that time, I was already working a lot, and I was studying at university, and so I got my first paycheck at the age of 13 as a computer engineer.
What?
Yes.
Wait, age of 13?
Yeah, but that was a summer job, right?
Yeah, must have been.
But I got the money back then, so that was like it was 13, so it was back in 1986. And since then, I was like working all the time. So I was studying, and at the same time, I was working. And at some moment, I was making really good money because at that moment, like I was still at school, but no one is like knew the computers. So the businessmen who was buying the computers, from China and from other places, they brought the computers. I was installing all the software, all the new software, tested it, and from each installation, I was getting like the amount which was equal to, I would say, like one cell. So if I'll translate the other, back then rubles to the US dollars, it was about like maybe $400, no, not $400, maybe $300 US, like per installation. And I was doing like two or three installation, like a day. Yeah.
And you were 13, right? That's a lot of money.
No, at that moment it was like that was back in around like 86. Sorry, not really 86, 88, 89. So I was like, at that moment I was like about like 16 maybe. But I was still at the high school and I was making the really good money. But that wasn't that long. But still, like I was able to make some little fortune.
That's pretty crazy. And you were just doing installations. Like you were just
installations.
Sitting there. Wow. So you weren't even like writing software, doing all that. That
is like
cool. Oh man.
I was at school,
Yeah.
just like at the higher, so the grade like 12, something. But like in Russia, we had like only 10 years of schooling. That's why we had they cramped too much of the information. So like at the grade 8, at the grade 10, we usually studied all that stuff. What even here, like in North America, I usually studied at the first. First years of the university, all that calculus and all that
Yeah.
stuff. Yeah, but that was fun. That was really fun.
Yeah. So after university, did you go into like software right away? Did you do something else in between?
I was working before university. I was already like working as a computer engineer,
Really?
and
Okay.
and
Well,
I
so
was
then
going
after
and
university,
I was going to the university just to get a diploma and maybe some more information. But at some moment it was funny, like there was like I taught computer programming to the
yeah.
teachers who were supposed to teach computer programming in the university.
Yeah. So a lot of people I know that went through university love Fortran. Like my professors still talked about Fortran when I was going through university, which was a little bit later. Like
Mhm.
in university, was it all C++ when you were doing computer engineering, or was it
No, it was
still
still
like any?
Fortran, a little bit Fortran. See, because I studied computer engineering, which is not computer programming, but it's like electronics and computer programming. And my
Oh,
term
okay.
paper, yeah, and my term paper was to build a modem.
Oh, wow. Wait, to
In
build a modem?
hardware, yes.
Wow.
And to program it. Yep.
Man, that's crazy. I was this could sound really funny, but I lived in San Francisco for a little while, and
Mm-hmm.
I was out at a networking event. It was like a bar, and there
Mm-hmm.
was a node developer I was talking to, and he was pretty young. I would say he was kind of in that early 20s, like 23, and he was talking about the TV, like where there's a TV at the bar, and he
Mm-hmm.
was like, I wonder how much information you could pass through like sound. Like you could have like a high sound be high, like a one, and like a low sound be zero. And I'm like, have you never
Mm-hmm.
heard of a modem? And it just
Mm-hmm.
dawned on me that he had never heard meh, meh, like he had never heard the sounds, like he had never heard a baud. Like I mean,
Yeah, I know.
he missed that entire thing, and I was like,
Oh,
it just
completely.
yeah, he just
Completely.
reverse engineered his way into a modem. And I was like,
I know.
it was a
But
funny moment.
the funny stuff is that back then, like I had my FIDO BBS, I had my
Yeah.
BBS and my
Oh,
FIDO
BBS.
node.
Yeah, yeah.
Yeah, and I had my FIDO node, and quite often, because I had allowed hours when they can call to my BBS, and so quite often they called outside of those hours, and when
Yeah.
I hear some kind of quietness, I said,
Yeah,
and
yeah.
the modern stuff and the other side start to to play the modern notes because they start the time actually the modem and I go
Yep.
I start to yell at them but exactly you guys gonna do not at the loud time but that was fine. I'll find out.
Yeah. Did you ever play Trade Wars?
Trade Wars, it sounds familiar but I don't remember, it was so long ago. What was
Oh,
that?
okay.
I played
It
Elite.
was kind of like
I played Elite a lot.
oh, so Trade Wars was like a kind of like oh man, I'm gonna explain it and someone's gonna be like, that's not it. It was kind of like Star Trek, and you would trade things and go from different spaceports and sell them. It was a BBS based game.
Oh, the
And
BBS games. No, maybe yes,
yeah.
but I played Elite mostly.
Oh, okay, okay.
Which is the same.
Someone spun up a instance of Trade Wars a few years ago as just like a hosted web service, and I played it for a little bit, and it was pretty fun. But I mean, it's so old in its style of gameplay that it's only fun for a little while before a little bit of it gets kind of annoying. But it was super interesting to see a BBS game be reborn.
I played a lot actually BBS games back then. It's all the test crawlers, or up, down, left, right, and whatever.
Yeah,
remember it,
yeah,
right? And at
yeah.
the same time, I love to play the Core Wars. Remember the Core Wars?
No, no.
Oh,
What
the
was that?
Core Wars. It was a small program where you ran the code
Mm-hmm.
that's supposed to survive, and at the same time, at the time, they kill the opponent's code, and
Oh,
and
interesting.
they do the same, and that was quite interesting, approach. So it's some kind of the programming, like the war of the programmers, because when they're writing the code, and so you have some kind of amount of the memory, and you have to build this stuff to survive it. So you
That's really
actually
cool.
can you can look at it. It's named Core Wars.
Core.
Yeah, like
Wars.
COREWARS. Yeah.
I kind of like the older style games in some ways where it was just a little bit more focused.
Hmm.
And like the open world concept games, they just get with, there's, everything from like crafting systems to weapon systems to skill systems and all this stuff. Like kind of the older style games were just they were interesting in a way that they had like a very narrow kind of like they were complex and they were hard, but they
Hmm.
weren't like you didn't have to learn all these different systems. Like they were pretty good.
Yeah.
Um,
Yeah.
and so, how did you get from that and kind of? I mean, what did you do next? Did you ever make it into Java? Did you kind of go from the traditional
You're
C
gonna
plus plus to
surprise.
Java
So,
route?
yeah, but because I started with assembly and with the C, I was really hardcore system programmer, right? So
Really
I always I
interesting.
always fight it for the optimization of the bio, all of the machine code to make it extra CPU
Yep.
cycle. And at some
Yep.
moment when I was building the Bresenham line algorithm, the Bresenham line algorithm, right? So what actually happens? I was optimized hardly, really, really, really hard on this assembly, build it, optimized everything I can do, and
Yeah.
then
Yeah.
it was about 80 bytes, something like that. And then I did the same code on the C,
Hmm.
optimized that code exactly, very strong, and then I put all the maximum optimization, and when I compared the code, it was almost identical. What I've built and
No,
what the C++
really.
compiler done. And so what I said, no, okay, now I forget about assembler and I do everything on C.
Okay. Okay. Wow, that's kind of crazy. And man, that's super fun. I always liked programming assembly in college, but after college, I never did. I love the kind of talking about, or at least do like thinking about the low level systems programming. But I don't do it. I don't do it professionally. I've never done it
Hmm.
professionally, so I'm kind of a little bit envious of that. So you went from assembly to C, and then what was
And
this
then it was
job that
C++.
you were doing?
And then it
And
was
then
C++.
C plus plus.
Yeah, and so back during that time, I was really working on different jobs, doing some drivers, some optimization stuff. Then I did some internet stuff. And I always tend to before going to Canada, and maybe before that, I tend to be system hardcore, system programmer. So I was
Mm-hmm.
working with the Linux kernel back in 1993, some cool stuff later on, when I moved to Canada, I started to I moved to Canada in 2000, so I started to play a little bit more with Linux kernel and build some firewall prototype, which I will talk a little bit later about it. It was fun, by the way. I was beating the checkpoint firewall like a crazy. Performance-wise, it was really crazy. But because I couldn't find because my English was not so good and I didn't know how to find the investors, so I just leave that idea. But then it's what I found that everything what I was thinking about, it becomes some kind of eBPF stuff. So eBPF, they kind of have the same
Oh yeah.
principles.
Okay.
eBPF, it's it's like Linux kernel, some kind of filtering stuff,
Mhm.
it's bytecode at the Linux kernel level. So it's Linux
There's a
kernel
yeah.
level. Linux kernel is executing the bytecode at the kernel level, and it's so freaking amazing.
Yep. Now there was someone that did a lot of performance work, and he was the guy who did like flame graphs. He was or made them more popular in my from my understanding. And he just did a book on eBPF, right?
Yeah, yeah. No,
Yeah, what's his name?
eBPF is good. Oh
Brent.
gosh,
It's Brendan Gregg. I think it's Brendan Gregg. Have you ever heard of
yes,
him?
yes, sounds familiar. Probably I saw his his publications. But yeah, so but back then it was I build my code when
Yeah.
you heavily optimized and what I will talk about it a little bit later because I'm just jumping on and off in the history. So
That's
back
fine.
in my Java experience, so I started to work with the Java experience
Hmm.
I started working with the internet around 1994,
Okay.
the
Okay.
when I started to work for International and Trunk Telephone Exchange, and that's the only internet you can get back
Well, I
then.
mean that's the crazy part, right? I mean, 94 to '01 wasn't that the telecommunications internet revolution? Everyone was buying everything. The stocks were going bananas. I mean, that's the time
Yeah.
to be in there.
But back
Yeah.
in Kazakhstan, it was completely not so much of the revolution, and the only place but back then, I used to work for the International Telephone Exchange for for a few years, and back then I was doing so because for us it was free access to the to any part of the planet because it's
Okay.
because they own all the channels, right? So we were downloading lots of the software. Like I was learning like a crazy and reading, and I started to do I became the first internet admin in Kazakhstan.
No way. What?
Yeah,
What? So this
So
is
I was
the wait. Is
I
this
was
the This is the thing where you can like get like IP blocks and stuff like that. Like this is the first this is the communication.
that's what
Oh
I was doing. I was I was getting I was actually helping them to build all that infrastructure for the
really?
modern tools, all that stuff setting it up, and building the billing systems around it to help them to charge the customers to use the modern tools. It was a lot of fun.
That sounds super fun. Oh man, did you? Oh man, that's super crazy. Did you run the domain name server for Kazakhstan?
No, not for the not for
No.
the .kz, but that one was handled by the Russian side because
Oh.
before it was Soviet Union, right? Before
Yeah.
1991
Yeah.
when all the
Oh
second
yeah. Yeah.
republics was disbanded and become independent, and because of that. It was handled by Moscow. But still,
Okay.
I was doing lots of the other stuff, and I did lots of programming over there, and that was fun.
Man, that's just such a different era, and it was like so fun. And I love reading about and learning about some of the networking stuff. I'm actually reading a book right now, No Better Time. It's about the Akamai, the
Hmm.
first CDN, and
Hmm.
talking about like the worldwide wait and all this type of stuff that went on during that era, and like the things that people were trying to figure out, and BGP, and
Yeah.
it was
But
crazy.
then
It
they
was super
lost it.
fun.
They lost it to the Cloudflare because
Really? Whoa. Okay. Okay.
Akamai was the biggest one,
Yeah.
for the CDNs, and now it's looking into but it's mostly for the CDNs. So now maybe I'm bullshitting here because you see the Cloudflare they do the protection, so they still may
Yeah. Yeah.
provide you for the CDNs, but
Yeah.
they may have, but Akamai also provided that kind of DDoS protection and everything like that. So everything
Yep.
was
Yep.
going to them. That's why a little bit missing out. But yeah, that was really huge. You're gonna be
Yeah. That was
surprised, but
massive.
but all the DDoS attacks protection which is done on the Cloudflare, it's done on
Yeah.
Linux boxes with eBPF code.
Yep.
Yeah.
I didn't know it was eBPF code. I have spoken to people from Cloudflare. I used to work at Fastly, and we used to talk back and forth with the different engineers.
Hmm.
It was like really interesting to hear what their problems were and what they were doing, and
Hmm.
yeah, they are awesome. They're a massive company. I mean, they've done a lot of really interesting work. And then there's Amazon with CloudFront. I work for Fastly. I think that's super interesting.
Hmm.
That space is becoming more and more interesting. I mean, it's not the same as the origin and the .com boom and writing the first CDN, but like
Hmm.
it definitely the work that people are doing now is super fascinating and super necessary. And I didn't realize they're using EBGP or eBGP. That is super cool. I want to know. I wonder if they've done a
No,
blog post on that.
it's not BGP. It's BPF, eBPF.
Oh,
It's
eBTF.
Berkeley for packet filter,
That's right. That's right.
eBPF. Yeah,
Yeah, yeah, yeah.
and BGP4 is different. It's no, it's not. No, it's no, it's routing protocol, which is I
Okay.
know quite well as well.
I don't really know it that well. I've heard a lot of people talk about it, and there's
Yeah.
a lot of
Oh,
people have done some really interesting things with it, but I have not.
border gateway protocol. But so if you know
Yeah.
how to read the BGP updates, from the history, you can see how the internet was developing over the time. Because all those updates, you can get you can access it from around maybe 1999, but
Yeah.
not that much. And if you will replay all of them, you will see how the you will see how the how the networks was added, how the routing was changing, all this stuff. You can even see the attacks. Like for example, when the hacker was able to like intercept the traffic and send it to their host instead of the legitimate one.
Interesting.
And
So
so all that
yeah.
history is stored. So you can go to the you can go to the right site or to the other ones and don't download those archives and just see the core wars in the network or in the internet.
That's super fascinating. So, like just moving on a little bit. So you
Yeah,
were doing this like core like networking stuff, and you were doing part of the internet. Like you were just kind of getting the internet up and running and being
yeah.
part of that
Back in
revolution. How did you
1994,
get
95.
to?
Yeah.
Yeah. How did you get to kind of like how did you get from there to where you are now? I mean, it sounds like you've done a few moves and maybe possibly changed a few languages, right?
Oh, back in 1995, like when I was young, I was learning the new languages like a crazy. So I could write back then. I could write on 10, 15 languages, and I could read about 40. Now it's
Whoa.
yeah, I knew I back then I knew Prolog. I loved it.
Okay.
I
You
know
did?
and did some stuff. Yeah, Prolog. I love it. I knew Lisp.
All
I
right.
hated it, and I still hate C, C++, basic assembly, different flavors of the assembler. I wrote first Java applet back in
Yep.
1995,
Yep.
and that was quite fancy one. Because I always when I'm learning new technology, I always trying to think of some kind of pet project to work on, because this is
Yeah.
the only way how I can perfectly learn the technology and what they can do with it. Because if you just read, you will not remember that. So you have to try it on something. That's why I always start some kind of pet projects I'm playing with. And
Okay.
yeah, so I built some kind of small applet, which was how to say it, it's some semiconductor skin
Okay.
where I have the central processor in this, in the center, with your logo and with the name of your company. Then on the side, it was programmable number of the buttons where you can put some kind of labels what they're supposed to do and some actions, and it will put it around that central unit, and it will create some the connectors, and it was
Huh.
kind of tracing in the same way how it's usually done on the in the tracer. So I built it on the Java applet, and it was quite widely popular between my friends.
Very
And so
cool.
they got it and they put it on their websites all over the place. It was so
Yep. Yep.
so
Back in the
fancy.
day where Java applets were all over the internet. And then
Yeah.
how
And JavaScript, and I started to do the JavaScript as well. But again, so I learned it, I tried it, but I didn't enjoy it because performance-wise, it was too slow, and because
oh my god.
I was always hardcore programmer. So I said,
Well,
okay, I
yeah.
know this stuff. Let's move on.
I
And
think people
so,
don't realize how far JavaScript has come. I mean,
oh
originally
yeah,
JavaScript I don't even think had the keyword this or I mean it was a completely different language at some points, right? Like it's gone through massive
no, this was
iterations.
there.
Oh,
Maybe
this was
I'm
there? Okay.
bullshitting, but I not remember. Back in '95, it was there. Maybe I'm
Oh,
mistaken.
really?
Maybe I'm
Oh.
mistaken, but I think it was there. But again, I don't bullshit. I don't really like to bullshit because I see
That's fine.
for me this it's natural. So that's why I don't remember if it wasn't there.
And then how did you get from 95? What was the so you've gone through Java, Fortran, C, C++, kind of moving forward, how did you kind of get to the point where you discovered Crystal?
Oh, so then I was working for the banks. I used to work for the French. Well, I used to be EDP manager for the French bank. So that was
Oh wow.
fun. They hired me, and back then I said that I know COBOL, but I didn't know the COBOL at all. They hired
No.
me and they sent me for the training to the Paris. And my manager, he realized that actually I don't know the COBOL. What he did, he gave me that was Micro Focus COBOL. He gave me
Yeah.
the book about the COBOL, about the Micro Focus COBOL. And while I was flying to the full, from Almaty to the Paris, to the Paris, I learned it actually.
I love it when people do that. There's a few
Again,
people,
buy the
yeah.
book. The same how I've done with FORTRAN.
I love that. So there's a few people I've known that have done like the, oh yeah, I know C++, and I'm like, really? And then they get on a plane, they fly somewhere, they take an interview, and they learned it on the way. I actually did COBOL in college, and I really enjoyed it, and I don't know why.
Yeah,
I
it's
can never
good.
tell you
Remember,
why I enjoyed COBOL, but like,
remember the Type 77, so Type 88. That was quite
I
fancy.
don't.
It was kind of like destruct and union in in C. So it was quite fun.
Oh,
I
interesting.
liked it.
I don't remember.
Yeah.
I don't remember that specifically, but I just remember really enjoying it. We actually did this one project where we had to take like a COBOL program, output some data on a mainframe, read it, do do like a separate program in assembly, and then pass the output from the assembly program out to a COBOL program, and then generate a report in COBOL.
Yeah.
And I could not tell you the exact things I did. I don't even remember the syntax really. I just remember that program was super fun. I loved it. I really enjoyed working on the mainframe. I thought it was like a really fun project to do, and I had a blast with COBOL, and I enjoyed I really enjoyed assembly. Assembly was my favorite, but I don't even remember. Like I remember some like small things about that project, but I don't remember specifically. I just remember loving it. But assembly,
Yeah.
like handwritten assembly, is super fun. We would do a few different sorts. And we'd write the sorts. Like we wrote the GNOME sort, which is an awful sort. You should never use it. But it's just like something that we wrote in assembly.
My
Like,
favorite
we
is
just
the
like,
merge sort.
yeah, I mean, merge sort is it's a very classic one. I think that one is it's a combination of a few
the easiest one. So like for me, the merge sort is easier than the quick sort.
Yep. Well,
And
I think merge sort
is about
yeah.
performance wise it's about the same, like and login.
Yep. Well, I think quicksort, if I'm not mistaken, someone's going to pull out their algorithms book and school me. But quicksort was it has less bad cases, there's less worst cases, right? So quicksort is used because there's less cases where it will have a worse performance, but it has similar performance to a merge sort on the average or normal case. Is that right?
Yeah,
I think that's from
my
it's a
little bit more stable. Yeah.
Yeah. Oh man, this was super fun. I remember, red black trees doing data structures and doing some algorithms classes.
Yeah.
This was,
but like my favorite, not red black trees, but AVL trees. I like AVL more.
Yeah. Oh really? I don't think I actually covered that in classes. I haven't really gone back, so I don't know that
because
one.
I see like red black trees like if maybe I'm mistaken, but I think because you see AVL, it was like that was like Russian algorithm. Maybe that's why, because they're kind of similar. But the idea is like when you the AVL is quite simple. Why? Because like when you're building and you put the counts, you just like to see how you have the on every count you have. So it means like you always control that your children is not deeper than more than 2. So all the stuff. So again, there's some kind of performance improvements over to red black trees, but in overall, the red black trees working a little bit better. But by some reason, I always liked the AVL.
Okay,
but they're similar again. I remember there was some kind of issues with the black trees recently, and they built some kind of new algorithm, but I didn't remember. I don't remember, so I don't want to bullshit because it seems like I stopped to do system programming for some time. But I still follow it, and I still do lots of the stuff for that. But again, so I usually have a motto to stop bullshitting and do some good stuff.
Okay,
so that's why if I don't remember exactly what was wrong, like with the algorithms, I don't want to bullshit again.
Okay. I remember my very first interview. No, not my very first interview. My very first job. So my very first job out of college, it was the interview for that job. And I was actually interviewing with 2 Russians who had immigrated, well, one Croatian and one Russian who had immigrated to America. And they let me sweat for an hour trying to do the depth first and breadth first algorithms for a graph. And I think I got it at the end, but they made me work for it.
But that's good. So I usually do the same. So when I'm interviewing the people, but I'm doing it differently. So what I do, I usually see how fast they can learn stuff, right? So if they don't know, I usually ask some kind of ever increasing complexity questions, which actually link it to each other, right? And I'm asking them, and I say what do you know? So what is this one? So how it works? And then if they don't know, I'm just explaining them what's supposed to be done, and then I ask them again and to
Okay.
see. And by the end, when I already explained how the stuff works, I ask them to build the task on
Hmm.
previously acquired information.
Okay. Interesting.
And it shows perfectly. Like, it just shows like how people can how fast they can learn and how
Yeah. Yeah.
can you
Yeah.
convert that knowledge to to the working code. And it will tell you about the people a
Interesting.
lot because I feel like I've done to all that stuff already myself, and I'm also
Okay.
the people who is curious enough. But that's that's how I usually do.
Very fun.
And
So,
I love to be interviewed and to be tested. But I love to go for the interview just to show myself, like, can I do it? Can I can I pass it? And
yeah, interesting. So kind of moving a little bit closer to Crystal. How did
yeah.
you get from there to like finding Crystal, or to
Oh,
see?
yeah. So like I was so when I was moving to the Canada, I was start to
Hmm.
work for UUNet. It's like internet provider, like a huge
Okay, yeah.
the backbone internet provider, and I built like my billing systems, like huge billing system. By the way, that system was working from 2000 until 2019 or maybe 2018. So for 18 years without any with the same old code I built back in 2000, and it
Wow.
was doing quite well. So that was a huge data, the huge database. So like they kept about like 2 billion records in the database, and it was lots of fun. So and then so that was built on Perl. Then from the Perl, I moved to Ruby like around
Yep.
2005, late 2005. So on Ruby, like
That was
I like
pretty
the
early.
yeah, I found that Ruby on Rails framework, and I said, okay, I want to try it. At that moment, I was working for the ISP Telecom. It's like in a small like CLEC provider here in Canada, and they had almost nothing back then. So I said, like, okay, guys, how about if I will just build your like telco provisioning system on the Ruby on Rails? Are you okay with it? And they said, okay, we don't care as long as it works. Go for it. So I used Ruby on Rails, and I've built their provisioning system with all the integrations for LNP, local number portability, wireless number portability, all the integrations with all other carriers. So lots of the fun. So that system's still working. Yeah.
Wow.
So I always
Is that
really,
system still
that's
going?
yeah, yeah. Oh, yeah. So
Oh
back
wow.
to from 2006. So now it's still 14 years and still going.
Wow. That's
Yeah.
really cool.
Yeah,
And
and
so you kind of
so sometimes I still support it, like help them like with the advices what needs to be done, maybe a little bit of coding there and there. But now I'm moving away from the coding more to the architecture because I do the architecture for a long time. Yeah, like I would say because it's still like my
Yep. Yep.
maybe like since 1995 or whatever, like, or maybe even before that. So for 25 years I do the and programming and architecture, but I enjoy more architecture because you have to keep way a lot of the information as an architect in your head than when you're
Yeah.
just programming because you have to keep like you have to keep thinking what may happen like in
Yeah.
10 years from now, in 15 years from now. That's why like all my systems is working for that long. Yeah. So back in the, back then, so again, I'm just jumping. So back then, like, I started doing Ruby on Rails. I really love the language. And so I said,
Yeah.
like, okay, it's fast. So like I will stick with it. No, sorry, not fast, but it's not fast, it's slow, but I love syntaxes. So I will stick with it.
Yeah. Yeah.
And so like I built that system. Then I moved to the other company who needed Ruby on Rails developers, but actually it was not Ruby on Rails but C Sharp. So again, on the interview, I had to learn on the fly C Sharp. I became a
Yeah.
C Sharp developer for some time. From the C Sharp, like then I started to work for the other company where I rebuilt their that was some a financial boutique. It's like hedge fund boutique, and I rebuilt their system from the scratch again. It was really slow for them. It was crawling. It was built on Ruby on Rails, by the way, but it was crawling. I tried to
Okay.
I tried to improve the performance, but it was like maximum what I was able to achieve is 25% improvement, but it was not enough. So I rebuilt that system on
Yeah.
the C Sharp, and
Oh,
then
interesting.
yeah, I rebuilt it, and so I did it back in 2010. So now it's 2020. It's still working. and it's
Nice.
flying. It's flying the same way. Like they finally, when I build the system, they finally get the speed they wanted. So I'm still working
Interesting.
there, and then, like around maybe 3 or 4 years ago, I saw the crystal, and I saw that
Yeah.
okay, this is actually Ruby and with LLVM, so it's so freaking crazy. I really like it. But again, I
Yeah.
played a little bit with it, but I didn't have enough time because I always like need to do this one, this one, this one. But I still played with it.
Hmm.
And so finally, because you see, for me, the biggest issue is because if I don't have really good debugger, for me it's
Yeah.
really tough to stick with with the language. And so I said, okay,
Yep.
like last year I said like like screw it, I really like the language. Like I hate Go. Like I don't like the Go at all. It's like it's a
I don't
little
either.
beyond, but syntax is terrible because like I love OOP, right? So like for me the OOP is a must.
Yeah.
And when I saw that, and when I saw the crystal, and I thought, okay, the crystal is really OOP where everything is there is an object, the same like in Ruby. That's why I love Ruby as
Hmm.
well. Where I
Yeah.
can say like one dot like our dot from dot now, right? And which
Yep.
will be
Yep. Yep.
amazing. And so I said like, okay, screw it, like I will use it for my project. So I start to work. I hate to put all that stuff like with put s or p. So I said okay, I will spend some time and I will dig into the code because code is good. So it's built on the crystal, so it's readable. Not perfect, but still like like I can understand what's going on. So I spend my time, and that's why I started that thread like about this debugging support on forum. And when I said like I
Yep.
guess like
Yep.
if I start to work on it, so I start to work on it, dive in. So remember like my old system programming experience,
Yeah.
and dive in. So I use too much of the put s in the debugger to be able to get like what I wanted. Then like finally when it start to work, the code
Yep.
start to
Yep.
work finally. Little bit of that one. So I start to mix put s with the debugging support. So like I debugged debugger with the debugger.
Yep. 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 That's pretty crazy. So I actually missed building a debugger in college. That was a class that I didn't take because I took a
Hmm.
different focus. But like
Hmm.
I know how to use some debuggers, but I don't. I'm not a power user of the
Hmm.
debugger. I always feel a little like I really enjoy debuggers. I can do a watch, I can do step throughs, and I can do different
Hmm.
things. And like but the like if you watch someone who really knows how to use a debugger, like really
Hmm.
knows them in and out, they can just get so much information and context out of a
Oh
program.
yeah,
It's amazing.
believe me.
And yeah, I don't know. I love the work you did with it, and I use it inside VS Code. And I actually tried the command line one, and it was too slow for me. I couldn't get the things I needed fast enough.
Yeah, the command line is
So
good, so you will use. But the issue with the code LLVM, they somehow screwed it because now it doesn't work. I don't know what's going on,
oh
but like like all the versions was working fine, but now it stopped to work, and I am trying to figure out.
interesting.
But yeah, so like I tried the like native native debug, so I don't like it because it doesn't use like renderers to show the proper
Yeah.
data. So that's why I use like Codillo. I found the Codillo VM. I saw that it's used on it. So I tried it. So I see it works. That's why I recommend that to everyone. But again,
Okay.
the issue is that like when you are running into something like the code which have some kind of deeply embedded like for example AST code, right? At some
Yep.
moment
Yep.
it's stuck. So it's like spinning and spinning and spinning. And to solve that issue, you have to go to the code LLVM and to disable dereferencing for around that time. So you pass that code,
Yeah.
like go back to the settings, enable dereferencing, and you can go again.
Interesting. So, for those who don't know, why don't we describe what a debugger is? I'm pretty sure most people will, but just in case.
So the debugger is the interface which allows you to snoop into your code. So for example, like it allows to execute your code, but not at once, but you are able to go and to say, for example, execute the code up to some moment and stop there.
Yeah.
And when then when it's stop at that moment, you can analyze. So what what do I have in the memory? Like why that added? or by
Yep.
that address. But if you don't know what address to look at, that's why we have the debugging support where we store the information about. So this actual address is this variable. So the compiler itself stores the information about the physical address and how that correlates to the variables that was in the code.
Yeah.
That's what gives the flexibility. So you can just analyze the memory as is, or you can get the value, and if you have the type information about that, if you have the type information about that object, so you can see and represent it in the way you want.
Yep. A lot of the information gets stripped away in production code, so we actually have to build code differently for debugging, right?
Yes, no, but you still can use it. So you can just you can still decompile the code with all the optimizations, all the production, all the release optimization. The code will be there. You still will be able to store the debugging information, but that information may be not correct.
Okay.
So you still can use it, but it will be not correct.
Oh, okay. That makes sense.
Maybe somewhat correct, because all
I
the
didn't actually know you could.
Yeah, no, you could.
Oh.
What happens usually, because when you have the debugging information, it's somewhat localized around one string. But when you do the optimization, so all those blocks can be rehash it and put in the more optimal way. So that's why you may think that you're on this line, but actually you're not on that line, because all that information is intermixed. That's the only difference. But but you still can access, if you know, for example, that this, because you see, if you know that you're on that line and you have that variable, you still can access to the value, in the memory, to the value of that variable and read it. But again, that may be incorrect information. That's why with the release, when you do this in the release mode, that information still kind of correct, but you cannot rely on it.
That's really cool. I gotta go try that. I'm gonna go after this call. I'm gonna go start messing around with some production code in debugger.
Yeah, you can do the release and then debug, and you will still see the fast code, but probably your line information will be screwed.
Okay. Another quick question then. I missed the debugger class in college. What are the parts of the debugger, and what do people know about? What do people, I guess, need to know about how it works? I know a little bit about some components, but what makes a debugger different than another debugger, and what are the different parts?
Usually, the debugger themselves, they're similar. So what they do, they just allow it to stop at some moment, analyze, and continue. So you can go up to the next breakpoint, or when I'm doing step by step. In that case, what it does, it moves. So there is the command which named I don't know what the bullshit right now. Is it C3 or CC? Not remember. So there's a very short command, one byte, which is actually that's C3, because int 3. Yeah, that will be C3. I believe it's C3. That code which is you insert. So when where CPU goes to that line, to that machine code, and when it executes, it calls interrupt 3. And on that interrupt, usually you have your code which will stop the application, get information, process, do some kind of operations in that in the way you want. And then it can continue. So, for example, you can say, remove that breakpoint code from the memory, replace it with the original one, and put that code somewhere else. So it will run, and when it will hit that breakpoint code again, it will stop, and again you can analyze. You can see what is actually in the memory, what is in the register, and everything like that. So this code is identical for everything. Not for everything, but for any platform. What the difference is, so for example, we have a dwarf protocol, which is the standard for all Unixes. So Mac OS, Linux, any kind of Unix flavor, they support it. And that's where they store all the information about how the debug information mappings are stored. So, for example, which line from like for example, this line get code from this byte up to this byte, like from this address up to this address. So for
Okay.
example, like all the information about the types. So for example, how the types are created, and that's what exactly
Yeah.
I was
Yeah.
doing, like through the LLVM, like inserting that
Yeah.
information. But at the same time, we have
Isn't this
the
where your Python code came into? You had a little bit of a Python patch, right?
oh,
And
the Python
that was
code. No,
doing.
that is for the LLVM itself, because it
Oh, it
instructs
is?
LLVM. It instructs LLVM how to read like that code and how to format and to show it on the screen. That's for the
Yeah, I
LLVM.
thought that was
I
a
have to do
formatter.
the same.
Yeah.
I have to do the same Python code for GDB, but because I'm the
Mhm.
because I'm the Mac OS guy, GDB actually doesn't really work on like on Mac OS. So like for that one, I have
Nope.
to use my
Yeah.
Linux like my Linux server. And because my
Yep.
Linux
Yep.
server is quite remote, like I'm quite lazy.
It's
Not
kind of
lazy,
funny.
but
Yeah.
I don't have enough time for that one.
I spent about 2 hours trying to get GDB to work on my Mac, and I,
I spend
um,
much more time with that.
put it into yeah, I put it into like single user mode and disable all these things and signed it, and
Yeah,
I couldn't get it to work. I have no
I
idea what's
did all
going
the
on. I can't
stuff,
get it to work.
and what at the end you get the zombie process.
Oh, really? I don't know if I
Yeah.
actually got that. Yeah.
No, it is because the GDP hangs. You have to kill GDP, and if you look in the
Yeah.
memory, you will see the zombie process of
Oh
your
man.
debug program. But that program is not in the memory. It doesn't take any CPU. It just records in the like in the tasks.
Is that? I wonder if that's a Mac thing, or I wonder if that would be the same. I don't. Mac does some weird things with so many things. I can't tell what's a Mac problem, what's like a Unix problem, like what's a
Yeah, but
GDP
at the
problem.
same time,
There's some interesting things going
LLDB
on in there.
works, and I also
Yeah. Yeah.
build like my own like I have my own program I built on Crystal,
Yeah.
which is actually doing some debugging. So I'm able to put the breakpoint. I am able to stop at that breakpoint. I am able to read some value from there, like or modify the memory in the value. So like when I run it, then you can see that that program is like showing some kind of modified value.
Yeah.
It's just like it's a very simple one. So I want to continue to make it like for the Mac
Hmm.
for the MacBook for now, because
Yeah.
that's Mac OS dependent. But I want to use that code for the debugging
Yeah.
one, because you see, I hate monstrous programs like GDB or LLDB. I don't understand that they must be flexible to work on different platforms, but for me, it's way too much, because I
Yeah.
always like I'm preaching the KISS principle, right? So like and I usually follow the same.
Yep.
I usually uh, follow what I preach.
People love that. Yeah. I like it. You mean to keep it simple, right?
Yeah, exactly. Because keep
Yeah.
it simple. If you want to be a great programmer, you need to know only
Yeah.
two rules.
Yeah.
Keep it simple, and also defensive programming. So never trust any parameters coming to your function, and
Yeah.
validate them and check for the null pointers. If you do that,
Check for
and
null pointers. Oh man.
yeah, check for the null pointers for the values within within the code,
Yeah.
and you're good.
I remember there was this one Java program I worked on, and there was a null check at the beginning of a really critical path function, and nulls kept on getting in. And for some, for some like trick of Java, for some like quirk in the language, like that specific null check like didn't work. And I don't remember what the specific detail was, but
Mhm.
holy cow, did we burn a lot of cycles in that problem. And nulls kept on getting through. We had a certain set of messages, and we could run them in that order, and a null would appear somehow in the middle of this function. It was just like it was the weirdest thing, but whatever. We got it fixed in the end. But it was definitely like a strange Java thing that I had never known. I
And
think
because
that
I'm system
people.
programmer, sorry, sorry that I mean to interrupt. Because I'm system programmer, I'm spending too much of the time with the Java, because like for some of my clients, I have to like they use the Java, and I
Mhm.
have to analyze the stuff. So I build like my Java. You can see actually, like I open the code. It's Java. It's a Java class and jar file reader. So which reads the information, and you can use it like for your stuff. I'm still like want to optimize it, and maybe to build like some kind of simple emulator, like in a Java emulator, when you can play and do some kind of analysis with that. So, but yes,
Yeah.
that is on my GitHub account, and you can look at the code. It's built completely on the Crystal, but initially I built that code on the JavaScript. Then I ported to this Swift, and then I ported it to the Crystal.
Okay. And for those that have not used a language that has a really good built-in debugger, because Crystal doesn't, or I'm sorry, not Crystal, Ruby does not have a great debugging ecosystem. It is hard to
Yeah.
fully understand the benefits of a debugger. I think we need like an article or something of like why debuggers are awesome and why, like, because when people come in from Ruby, I don't think there's like a debugging like culture. But if you've ever been in a language where debuggers are like C++, if you know someone who
C#
can rock a C++ debugger or a C# debugger, holy cow, you can get a lot of info out of there, and you can like so much like makes sense. And I mean, it's just interesting. I think that like in some cases we just need a little bit of an update on why certain things, why debuggers make so much sense, because
I can tell you. So think of it. So like Ruby debugger, or the way you test it. It's like if you if you just writing on the buggy, like buggy or small toy cart, right? And when you start to use really good debugger like C# debugger and whatever, it's like if you're sitting in the luxurious limousine and driving really high speed, really comfortably. You can do anything just from you can just touch and it will work. It will show you all the information. So it's like you are a kind of semi-god which have all the information about your application.
Yeah, and like. Yeah, so you get all the information about the application. There is a really cool thing too, where you can like, when you're in a debugger, you can like in Ruby, and you drop into a pry, you start typing variable names, you start doing different things, and you in other debuggers, like all that stuff is there, and you're just watching it change in real time, and you can manually manipulate things. It's a different window into the program, and you get a lot of granularity and control all at once. I think that like I don't know. I just wish that someone who knew a lot more about debuggers could do like a really great
Why
tutorial.
Pry is good, but the Ruby right now have a really good debugging support. So finally, with that ID debugger, whatever it is, plugin, which is part of the Ruby mine, and so you or even individual studio code, you can do they have really good debugger support for now. So you don't have to use Pry for that.
I didn't know that. I want to go check that out now.
Yeah, but so your individual study is a little bit finicky, but yeah, it gives you all information about the variables. You can see anything, you can go through, or you can you can download RubyMine, which is doing that for a very long time, at least for 10 years. Definitely, they have really good debugger support.
Oh, I didn't know that. RubyMine, you have to pay for, and I really like RubyMine.
They have trial. Actually, I have my license.
Okay.
I paid for the license for Ultimate version, so I have everything.
That's interesting. The one thing about RubyMine too that I really like is you could right click on a class and click show me the file that this comes from, and it was not going to grep. It was not. They had some algorithm for lookup to file name to something. They had some really good features in RubyMine.
Yeah.
I think the one thing that keeps me away from that program specifically, because I have used it in the past and I have purchased it in different workplaces that I've worked at, so just like different businesses. But the fact that you have to do a subscription really turns me off from it, and I think I don't know if I'd buy it now. But
what you can do, what I've done, so I bought my personal subscription, so I paid for that.
Yeah,
and I bought in that Ultimate one when you can use everything, it's an toolbox. So you're paying about $200 US a year, I believe.
Yeah. Okay.
And or maybe to 4, and I'm not one right now. And then you can next year you're paying 150 only.
Oh, okay.
So I paid for 2 years, and now I stopped it. So I stopped it. I canceled my subscription, and I still keep my old code. Now I have my code. Maybe it's not that new. Maybe it's half a year old, and that's what I will keep for forever for all the products for IntelliJ, Ultimate. For I will use it probably 2019 instead of 2020.
Nice.
But it's still it's still good code. Still good code. It's more than enough. I can recommend the same.
Yeah, they have a really good database tool as well. I forget what it's called. Data miner.
Data grip is good. Data grip is good. Yes.
So I mean, I would like it. If I could buy a license, I'd probably own one. I might do what you did. see if I can. And
It's not expensive for the toolbox. It's a must because you will get everything. You get the C line. By the way, like when I was debugging, remember, initially I saw that the issue with the debugger of GDB. Remember, I said, I was able to fix it, and so to find that fix, I was using the C line to debug debugger.
Interesting. Oh, that's really cool.
Yeah,
I'll have to check that out.
I was a little DB itself. And I used C-Line for that, and it was really, really, really convenient.
I heard a lot of people really like C-Line. I think it's really cool that you've worked on the debugger. I just wish that we could get it some more. I think the response has been really good. You had a ton of stuff on the original forum post. You had, the PR one had a lot of comments and a lot of interest, and your follow-up post got a lot of traction compared to all the posts on the forum. So I think people like it. I just wish that I could show people why debuggers are cool. And I kind of wish that I'd understand more about them.
I will try to make the screenshot. My next step will be to make the screenshots, and now I have to figure out the time to make the screenshots, and then I will just post it. Maybe I will create my blog on my website. So the final stuff I have my domain name, but I don't have my website because I don't know what I should tell about myself. I provide the services to companies, right? For the architecture and whatever, but I don't know what should I tell about myself because I know too much.
Can do FORTRAN. Will FORTRAN for Will FORTRAN for
security. I have lots of experience in reverse engineering.
Oh, you've done security? Yeah. So I want to cover some more things.
Security for this moment. Yeah, I do.
Okay.
I work for some more fintech companies who I provide security stuff. Yeah.
Okay. I want to cover. I want to cover a little bit more things about the debugger before we move on to security, but I'm definitely taking a quick note about that. The biggest thing is that I'm really curious, when designing a language, almost everyone I know that's built a debugger has built a Lisp debugger because that's the college thing to do. But what makes a language better or worse to integrate with a debugger? Are there design decisions that affect the ability to be able to use a debugger?
Yes and no at the same time, because you see, as long as you can stop program at some moment, as long as you can access the information in the memory, as long as you can understand what that information, how to show it on the screen, you're good.
Okay. So there's not really for example, Ruby seems to be a difficult language to build a proper debugger for. Is that a language problem or is that a tooling problem?
I don't think that Ruby have the issue with the debugger because it's still, the debugger I was talking about in the Ruby one, it shows that it's fine. And that means, if you're able to stop the program, at that specific, but again, because it's still, that depends how you implement your virtual machine for the language.
Okay. So there is a little bit of a virtual machine design thing to make a debugger more or less accessible to the user, right?
Yes. That's definitely. So if you implement that code, in the compiler, and if it will be accepted, so then you will be able to see anything.
And how does Crystal compare? Was Crystal a language that its design was amenable to having a debugger?
I'm sorry?
Was Crystal easy to implement a debugger for? And is there any compiler feature or change that would make a debugger easier in the language?
No, because I see here the Crystal is piggybacking on top of the LLVM, and because of that, you have to use LLVM infrastructure. And so this is the reason why it took even for myself a long time, because I see and I have lots of experience, right? So it took me half a year to be able to make it right, and I spent quite a lot of time on it. And the issue is to understand how properly to integrate it. You have to dive into the LLVM, LLDB, the debugging information, how they read it, how it understands, how they process it properly, what needs to be done. And so if you understand all that stuff, if you have really good experience as a system programmer, for example, then yes, you will be able to build that. But you see, right now, it's not many of system programmers. So, most of the people they're trying to use the higher level languages, and they lose that grip on the low level, right? Because you see, for me, I hate to have black boxes. If I don't understand how stuff works, for me, it irritates me. So I dive into the code as deep as possible. And if I understand, for example, how it works on the CPU level, even on the semiconductor level, or like on the level how the MMU works, or for example how all the pipelines in the CPU works. So when you have all
Yep.
the information,
You're talking some pretty deep levels. For
yes,
people who don't know, MMU is memory management unit. I think you discovered you're talking about
yeah,
registries, which are kind of like variables for CPU. I mean, you're at a level that I really love talking about, but it's not discussed that much.
I
I'm really
know, but you see,
curious. Yeah.
but also I knew about the Elon Musk maybe 10 years ago, and probably the first time I heard about him, and about his first principles. But I was using the first principles before, way before that. So for me, the first principles is a must. If you want to understand stuff, dive in,
Yeah.
because
Yeah.
you must understand how it works on the very low level, on the level
Yeah.
of the atoms, and up, and up. So then you just building the abstractions, which is just reading and understand. So you don't have to remember everything. But if you work in this level of abstractions, but you at the same time you keep in mind the information around it, so how it's actually
Yeah.
working on the low level, you will understand much better, and you will understand about all the consequences.
100% agree. I'm really curious. So in the previous performance work that I was doing, even some performance work in Ruby, I was measuring L2 and LLC cache misses. So L1 cache misses, I couldn't optimize in Ruby. Like they're that's a whole other problem. But I wonder
L1
how.
still can, because it depends on your cache, how much of the bytes you will put into the cache and how it's aligned. That's
Yeah.
what the L1 and L2. It's all about
So
alignment.
so for people who don't know, we're talking about the caches inside a CPU. So inside a modern CPU, one that's been made in the past 20 years, there is a level 1, level 2, and a level 3 or LLC cache, and then RAM. And the more things you can access from the closer or the lower numbered caches, the faster your CPU can execute something. And so it's a very good way to optimize a program, because it's an incredibly long round trip to RAM, which sounds funny, but it's true. So that's what we're talking about. And I'm really curious. I haven't really done any of this work inside Crystal yet, but I should really go back and apply some of those methodologies to see, kind of how Crystal compares. I mean, some of that stuff when I was doing some stuff with Ruby, it was about optimizing cache lines and using smaller objects. And the smaller objects, the less cache you evict and that kind of stuff. So I'm sure you could apply some of the same principles to Crystal. But it'd be interesting this comes down to using a good debugger and getting the right info.
Because LLVM is doing it for you.
Yeah, it's true. Well, LLVM can do some optimizations for you, but if you still have a really fat struct and you're pushing it through, you're pushing through all the caches, you're just going to evict a lot of things you don't want to evict. Yeah. So, I mean, there's some interest. Like some of this stuff is just like understanding low level stuff. Some of this stuff is having the right tools to be able to get CPU counters and other things out of there. And some of it is like debuggers. And I think that there's a lot of really interesting low level stuff that if people knew, they'd be able to make their programs faster, understand what's going on.
Yeah. For example, when I was working on the firewall, I was talking about, and I want to talk about a little bit, back then. So I was able to optimize the code in the way so I can find any rule, from 1 million of the rules, I can find that in 100 CPU cycles.
Oh wow!
Yeah.
Wow. That's crazy. And so for people who don't know, cycle is a generic count for how much work or for what a CPU can do. For example, like you can do an instruction, but you can also do 10 or 5 instructions inside one CPU cycle. So
because they parallelized.
Yeah. And then
so that's how I was able to achieve on Pentium 3, 500 megahertz. I was able to achieve 420,000 packets per second.
Yep.
With 1 million rules and connections.
That's bananas. That's super cool.
And back then, the checkpoint firewall, it was back in 2001. Checkpoint firewall with 1 rule and 1 connection, and with 2 CPUs, the 3 gigahertz was able to make only 160 packets per second.
Yep. That's crazy. I mean, yeah. Oh man. That's some fun times. I didn't even know that's a lot.
Yeah, I know.
And you're talking about packets, so that's you're pushing a lot of data through a CPU. That's interesting. And then
That's why you're
firewall
using the DMA.
stuff.
It's even more low level core stuff,
Yeah.
like how to use the DMA to move the data without using the CPU and all this stuff. It's crazy. I still love it.
Yeah, it's super fun. It's a world that I don't interact with as much, and it's a super interesting world. I'm not really aware like where the big system programming jobs are out there. Like, I mean, so much stuff has been pushed into web applications that I feel like
Yeah.
whenever I look around, that's a lot of the jobs that are out there. But system level programming is, for those who are interested, it is super fun, and the history is fascinating because people have been doing crazy stuff at low levels. So like you talk about, now, kind of the progressions that are made, and even just talking about what AMD is doing in the past few years and why they become so popular
With
with
Reaper.
their chiplet design. I mean, the chiplet design is changing is changing the PC landscape.
Yeah.
So.
Yep. But man, it's really fun. So we talk about this forever, but
Yeah,
that's the time we have to probably
it is true.
wrap up.
Yeah, it is time to wrap up. Thank you for keeping me on track. We'll have to make another a call and talk about security sometime, because I'm super fascinated in security in general.
I do the security.
But
yep.
Yeah. Well, why don't we end with, what are you working on these days? And if people wanted to find you, where can they find you?
So I have my company, IT Audit, where it's my consulting company. So I provide IT second opinion because of my extensive knowledge at cloud computing, at security, at solution architecture, to cloud architecture, solution architecture, cloud security architecture, software architecture, DevOps, DevSecOps, automation QA, blah blah blah. So because I consider myself as IT generalist who knows not just a little bit about that, but quite a lot about all that stuff because of my 37 years of experience, right? And because of that, I trying to apply a holistic approach on the problem. That's why all my systems working for so long, and I'm still trying to help people to improve the stuff. So, for example, I provide services like CTO as a service, when as a CTO advisor, so when I can look at their issue and provide them second opinion about what they have good, what they have wrong. They can also ask some other opinion, and then just to compare, and based on that information, it helps them to understand their problem and how to solve it better. If they need it, I can help them as well. So I have my team in Belarus who may help me to build some code, because as of myself, I'm building only all the proof of the concepts, and when the real programming goes, then I'll just pass it to them.
Okay. And for those who didn't hear, what is that URL one more time?
Oh, my company, and it's iterodit.com, but it's nothing there. So if you guys want to contact me, you always can, feel free to contact me over my, my LinkedIn, send me LinkedIn request to contact with me. You always can find me by Sergey Kuznetsov, IT Audit Inc., or you can send me the email, or you can find me, you always can find me on the Crystal channel.
Okay.
I'm on the Crystal Slack, so I'm always there. You always can send me the message there.
I think that they got, we have some instructions now for your LinkedIn, but what is your email, just in case people want to reach you?
So my email, you can send it to Sergey, SERGEY, at iterodit.com. And the IT erudite means the erudite. It's the guy who knows everything, who knows everything. And in this case, it's just about IT.
Okay. And for those who are looking for us, this is Chicago Crystal. You can find us on Twitter, and we have chicagocrystal.org for our website. If you want to look at our LinkedIn, and on YouTube, we are also Chicago Crystal. We do not have the name yet, so if we get 100 subscribers, we will actually claim the name Chicago Crystal. And I am Jack Thorne, and I am 123 on the internet, WONTRUEFREE. And thank you for listening to Chicago Crystal, and we will see you all soon. A big thank you to our producer, Christy Flores, who edits these podcasts, and our DJ, Bill Wesley, who provides the tracks and samples for these episodes. This was an episode of Chicago Crystal, building community and getting stuff made in our favorite language. We'll see you soon.